right? 16 in Spanish. Maybe that helps you. Okay. I think I did fill this in partially. And I hope you did the homework because I did scan this. Maybe I will just show you a bit of a pattern here. I scanned this one, right? And now looking back, maybe I should have asked you to graph at least one of them down here, but that's okay. We just had to realize these are all in vertex form. I wanted you specifically to be able to state the vertex by looking at the equation and then having to find the y-intercept using the calculator. And you did have a 41 here, right? This one was a bit bigger, a bigger number. So you did have to play around with your screen on that. So that's the main thing that the vertex form tells you is it gives us the vertex, but also the number of x-intercepts. It tells you that flat out, and I'll show you now if you pay attention. So here it is. Let's go to this page, and we're just going to focus on how can we tell just by looking at the equation how many x-intercepts there will be. Okay, and here's the deal. If a and k, how about I do this one more time? Let's write out the vertex form. Otherwise, notice that everything is plus here. It's just because this is a general form. Obviously, you can have negatives. But if you have the vertex form like that and you focus on A and K, right? So if you focus on A and K, so as H and K to get us the vertex, but A and K is going to tell us how many x-intercepts are there. So if A and K have the same sign, if they have the same sign, there will be no x-intercepts. Okay, why is that, Mr. Dirksen? Well, if A is positive, then you're pointing up. Right? If A is positive, we're pointing up. So this would be in the scenario where A is positive, and this would be HK, right? The coordinates of that vertex. So in this case, K is positive. How do we know K is positive? Because we're above the x-axis. Is that blurry? Let me just focus here. Focus. Okay. So A is positive and K is positive. So they're the same sign, no x-intercept. It will never cross the x-axis. And the same goes if they're both negative. If A is negative, it points down. And in this case, H negative K, right? K is negative because you're below the x-axis. If they have the opposite sign, if it's opposite sign, then we'll have two x-intercept, right? So if A is negative, it goes like this, A negative. But if you hone in on the vertex, if you zoom into the vertex, we know that it's going to be H positive K, right? We know that the y value of this vertex is going to be positive because it's above the x-axis. Same thing here. This one has a positive A, right, because it's pointing up, and the coordinates would be H negative K. So opposite signs, you have two x-intercepts. So I'm going to circle the x-intercepts, right? And last but not least, if K is equal to 0, sign of A does not matter. Because if K is 0, you're right on it, right? So H0 or H0. Right? So if K is 0, it doesn't matter if A is positive or A is negative. It doesn't matter. You're just going to have your one x-intercept. So I'll give you an example. Y is equal to negative 3x, oh sorry, negative x minus 5 squared, there's a 0, right? In this case, it's invisible, but technically k is equal to 0. If all you see is that k is 0, you automatically know only one x-intercept. Okay, so let's figure that out just by looking at these two equations. Tell me, look at these two and tell me, justify it as well. You can say, right, the signs are different. A is this, K is that, signs are different, therefore this many x-intercepts. So based on what we just talked about here, tell me just by looking at these, how many x-intercepts you expect there to be. So go to town, I'll take it over in seconds. To do it the exact same way, right? But A is negative and K is negative, right? So A is negative, K is negative. Therefore, have you seen the 3 dots? Some of your teachers may have done that. That's a therefore symbol. No x-intercepts. 0, okay? Brave volunteer for this one? 2? All right. Xander is the brave volunteer. Thank you. A is positive and K is negative. Oh, okay. Same sign. Let's make sure, because it's like, hey, we know that they're negative and negative, but it's the fact that they have the same sign that brings us to conclude that there are no x-intercepts. These have opposite signs. Therefore, 2 x-intercepts. You could enter it into a calculator and figure out, right? I'm going to do it at least with 1, so you don't just take my word for it. Zoom standard, I'm going to clear that. Let's type this one in, negative 2 x plus 4 squared minus 5. I went to a standard zoom, by the way. There it is. You can tell it's never going to happen. I'm going to go y2, the second y, and type in this one here. X minus 3. And then I trust that you will just take my word for it. There's that second one, right? 2 x-intercepts for this one, no x-intercepts for that one. There you go. Ta-da, right? Just like that. Next, this one is somewhat new, but I expect you to be able to do this. Right. I expect you to be able to do this part. So I'm going to do one, and then you're going to do one right after me, okay? Because I need to make sure you understand how to do that. I'm going to highlight this part. Calculate the y-intercept algebraically. Calculate the y-intercept algebraically for both of those equations up there. So I like to show my work here. So I'm going to say, if you had this, and you did this for linear equations last year, you did the same thing, it's just a little different because of the square. I'm going to zoom into that one because I kind of going to try to keep my work down to that corner. So when you're trying to find the y-intercept, right, x is equal to 0, right? When you're trying to find the y-intercept, x is equal to 0. That's very important. So when we take this equation, we're going to say, okay, y is equal to negative 2. We insert 0 for the x value right here. I'm going to use a red pen. Okay. 0 plus 4 squared minus 5. This gets ugly. There are decimals, but you have your calculator to help you out. That's negative 2, watch this, 4 squared minus 5. Because 0 plus 4 is just. You may, at times get, let's say you get 0 minus 4, then this would be a negative 4 in here. But do you remember what happens to negative values that are squared? Do you remember what happens to negatives that are squared? It's always a positive answer after all. Right? You just got to make sure you understand that. Negative 2 times 16, right? Because I square that, minus 5. And then it's negative 32, because 2 times 16 is 32, but it's a negative here, minus 5. And we're almost there. That would be negative 37 in this case exactly. So the y-intercept is 0, negative 37. You just found that algebraically. We used to use our calculator to do that, right? Second trace 1, x equals 0. But this is another way of doing it, okay? I want you to try, make a line here, and try the same thing with the other one you saw for question B. So this one up here, the 4.8, I want you to do the exact same thing with that one. Mr. Dirks, do I need to show the exact same number of lines? No. You don't. You can shorten it a little bit, but I should see at least 3 lines before you have your final answer, okay? At least 3 lines. So try it using this one here and solve for y basically. And then we're going to move on. Don't know where you're at, but here it is. Actually, because it's in function notation, you can actually say f of 0, right? Because x is equal to 0. And you just go ahead and plug in that. So that's 4.8 negative 3 squared minus 6. Can I just show you here? Some students, I don't think I covered this the first day. If you go negative 3 squared without the brackets, it's going to go negative. It's going to stay negative because the square is just squaring the value 3. So if you want to have it correct, right, you need to use your brackets accordingly. Okay, so that's important. So that'll be 4.8 times 9 minus 6. And then you can go 4.8 times 9. That's fine. That's 43.2 minus 6. Right, and then you just go minus 6. That's 37.2. So the the y-intercept for this particular one is this. Okay, so you actually know 2 points already for this one. You know what the vertex is, right? Let's go back up and just state that. The vertex would be what for this one? Positive 3, negative 6. And the vertex for this one would be negative 4, negative 5. So for both of these graphs, you have 2 points just like that. Boom, right? You could actually, you're very close to finding a third and then graphing it if you wanted to. Okay. So why am I doing this? We want you to understand what's happening in the background. We don't just want you typing buttons. We want you to know, okay, I can do it this way or this way, right? This is always an option for you to just find the y-intercept algebraically. Okay. All right, I think I wanted to do more, but I'm gonna just give you some class time to get going here. If you just look up, I'm gonna explain the homework. So I'm gonna say 17 to 18. That's it. I hope you're keeping up with it. I think that the speed is gonna be affected. Like if you don't do homework, you're gonna, on the test, you're gonna struggle with time because you're slowly figuring stuff out. But if you do your homework, you're gonna have some some cheats, some quick ways to like speed things up. And so my boys are video gaming a lot more than I like to admit, but there's lots of cheat codes, right? Cheats. So anyways, so for this page, write an equation that satisfies the following conditions. So I'm mixing up vertex form and general form already. Can you write it? Can you write that equation to make it work? to fulfill the requirements. Can you do that? That's important to me to understand that you know how to do it. Then down here, I'm going to make an adjustment to this one. It says here, graph the following without using a graphing calculator. This is optional. You can use TI 84 if you can do it with a graphing calculator. We're in business. I'm never gonna ask you actually completely out of nowhere to do it without a calculator. So I showed you how to find the vertex, how to find the y-intercept. So there are ways to graph it without using the calculator. I'm just gonna say use the calculator if you need, and include the basic things that you always need for a graph, right? And then graph that. And go to 18 with me. I'm asking you to do what we already have been doing, but I need you to take the time because they're all a little different. They're all different. So for each of the following, right, I want you to tell me what the width is, the direction of opening, state the vertex, calculate the y-intercept algebraically, explain how many x-intercepts, like how would you, it doesn't have to be a sentence, you can just refer to A and K, and then graph it. That's your favorite part, I know. Can't wait for that, right? So somewhere on here, my key, I haven't graphed it yet, so I need to graph it. But I'm going to graph it here for you. And you do the same thing for both of these questions, all right? And this is where I want to end today. This one has no x-intercepts. I don't have to tell you that, you should know by looking at it, right? Can you see it? A and K, same sign. So it's a struggle to graph it. It's a struggle to graph that one. So I will just tell you this. I will say this: use second trace 1 x equals. Use this and type in x values that you would like to find the y value for. So you just come up with 3 points to find 3 points, right? So in these cases, as long as you have 3 points, we're in business. I don't know what you mean, Mr. Dixon. This is confusing. Okay, I'm going to make one for us here. Okay, I'm going to use this one because I know that one doesn't have, this one doesn't have either, right? So you find the vertex, second trace max. Let me find it. Oh, that's another good point. Sometimes your cursor won't show up. So you need to use your arrows to look at the y. If I go left right now, my y value is slowly coming up, which means the cursor is coming up. There it is. So I need to go to the left of it, enter, to the right of it, enter, enter. So there's your vertex 4, -5, which I already knew. I knew what that was just by looking at the equation. But here's, find a value to the left of it. So that would be -4 or -5 or anything like that. Okay, so this is what I do. Second trace value, and I'm going to go maybe -6. X is -6. What's y like? And it tells me it's -13. So there's a point somewhere down here called -6, -13. And then I'm going to go second trace 1 again. And now I'm going to go to the right of it. So I'm going to go 1. Let's try that. That's -55. Maybe it's not a good choice because it's way down there. I'm going to go second trace 1 again and see what is y like if x is equal to, why am I going positive? Sorry, I should have gone -2 like that. Then you're at -13. Oh, I did that one already, right? Dirksen, you're confusing me. Sorry. I'm going to go -5, like further to the left, and that's -7. So try to find vertex and then some point here for the left leg, and then another point for the right leg, and those 3 points then connect and graph. The y-intercept would be good too. right? Find the y-intercept if you can, and then graph that as best as you can. So this one is a bit of a challenge, but I still would like you to try that. So 17, 18, that's all. And tomorrow we'll look at something a little different.